Hi guys and welcome. In this video I'm going to train you on the algebra portion of the NBT examination paper. If you have not watched my video on trigonometry, please go and watch that video where there's about 10 questions which is beneficial and it will prepare you for your NBT examination if you have not written them as yet. Let us have a look at the topics that we're going to cover. So in the algebra component, so we have algebraic expressions and simplification, equations and inequalities, exponents, logs and surds, factor and remainder theorem. So let us get straight into it. Question 1, solve for x. Alright, so we want to solve for x. 1 minus 3x. Remember, this is a rational, right? It's a rational inequality, right? What we do in a rational inequality, make sure that this side is always greater than or equal to 0. So what we do is we make the numerator equal to 0 to get critical values. So we have to go and factorize this entire expression and do not drop the denominator. So 1 minus 3x over x plus 1 into x minus 1 is greater than or equal to 0. Remember, we have restrictions for the denominator. X values cannot be equal to minus 1 and plus 1. So if we solve this, we have three critical values. The critical values are 1/3. If you solve the numerator equal to 0, you're going to get, what are critical values? Critical values are 1/3. From the denominator as well, we get plus 1, plus and minus 1. So if you write them in order on the number line, we get minus 1, 1/3 and 1. Now we want to figure out the signs in between. So there's 4 parts here and we want to write down the signs. So take any value which is greater than 1, or you can look at minus 1 and 1/3. Remember, 0 lies here. So if I substitute 0 on the numerator, I'm getting positive, and I'm getting a negative here. So positive over negative, I get a negative, and then you can alternate the signs because these are linear functions. So these are linear factors. So plus, minus, and alternate the signs. So plus on the side. And remember that x values cannot be equal to plus minus 1. So I'm going to open the circles here at minus 1 and 1. And at 1/3, we're going to close the circle because the value of x can be equal to 1/3, where the numerator can be 0 but the denominator can't. So if we want to solve for greater than or equal to 0, we're looking for positive answers. Positives are going here and is in between. So the solution to this problem is x is less than minus 1, or x is greater than 1/3, greater than or equal to 1/3, but less than 1. So this is our solution. Let us have a look at part B. We want to solve for 2 to the power x into x minus 1 is less than 0. In order to solve for this problem, what we can say is, remember, 2 to the power x is always positive. 2 to the power x is always positive. So you can just drop 2 to the power x. Therefore, what you have is x minus 1 is just less than 0. Solving for this, we can have x minus 1. X is just less than 1. So that's my solution to this problem over here. Log x minus 2 base 3 is less than. Now when you have log function, see, if you have y is equal to log x, the domain of a log function is always greater than 0. So in this case, the log function is x minus 2 greater than 0. Therefore, x is greater than 2. That is one part. And now we have to go and actually solve. We have to actually go and solve the log inequality, and we have an and component. So log x minus 2 base 3 is less than 1. If we want to solve for x here, we need to convert it back into exponential. So we can say x minus 2 is, the base remains the base, so 3 to the power 1, right? So what we have now is, remember, if 2 to the power y is equal to x, then y is equal to log x base 2. So all we are doing here is we're just reversing this process, right? So we got log x minus 2 base 3, which is less than 1. So 3 is a base. Remember, the base is here as well. So 3 to the power 1, x minus 2. So what we have is x is less than 5 if you take the 2 over, if you solve. So we got x is greater than 2 and x is less than 5. If we put it on the number line and try to understand what we're doing here, is this first part is telling me is greater than 2, so it's going that way. And the second part is telling me that it is less than 5. So the second part is telling me that, alright, I must go less than 5. And this and means I must take the intersection of the solution. So if I take the intersection of the solution, I will get my final answer to be 2 is x is greater than 2 but less than 5. So 2 less than x less than 5. That's my solution. Let us have a look at this. Third problem. Fourth problem, D. 2x minus 1 into 2x plus 3 into x plus 2 over x squared minus 4 is equal to 0. So let us solve for x here. So we have to factorize. We got 2x minus 1 into 2x plus 3 into x plus 2 all over x plus 2 x minus 2 is equal to 0. So if we want to solve for x, remember we can take out the x plus 2 and the x plus 2. And if we want to go and simplify this expression further, remember we need to cross multiply. So this times this is 0. So this implies all we are solving for is 2x minus 1 into 2x plus 3 is equal to 0. Therefore x is equal to half, or x is equal to minus 3 over 2. Hence, if you want to find the sum of the solutions, so solution sum is half minus 3 over 2, and half minus 3 over 2 is minus 1. Remember, no calculators are allowed. Question 2. Find the value of p plus q if x plus 1 is a factor of both these polynomials here. We have one polynomial here and, sorry, we have an expression here and another expression here, or a polynomial. So if x plus 1 is a factor, remember if f of x, right, if f of x is equal to x plus 1 into x plus 3, I'm just giving an example, and we say that x plus 1 is a factor. If we say that if x plus 1 is a factor, this implies that we can say what is the value for f of minus 1. See, the 0, it will give you a 0. So if I substitute minus 1 inside here, I'm just getting an answer of 0. So let me substitute minus 1 inside here. If I substitute minus 1 in this expression, I'm going to get 3 into minus 1 cubed. So that's 3 into minus 1 cubed plus p into minus 1 squared minus 3 into minus 1, and I'm going to get 0. So we have over here minus 3 plus p plus 3 is equal to 0. Minus 3 plus 3 cancels out, so therefore the answer for p is just 0. Let's look at what the answer for q is. Remember, we're going to substitute value of 1 inside here, minus 1 inside here. So we're getting minus 1 in the place of x. For this expression here, it is minus 1 minus 2 into minus 1 squared, which is minus 2, sorry, that's minus 1 times q, which is minus q minus 2 minus 5 is equal to 0. So if I have to solve for q, just take this q over, so minus q becomes plus q, we're getting 7. Therefore, what's the answer for p plus q? P plus q is just equal to minus 7, because 0 minus 7, which is equal to minus 7. That's your solution. This is a nice question on operations, right? Right, algebraic operation. So what you have over here is, this is just basically an operator, right? Let me just take out this operation. This is this star with the time, the circle with the time is just an operator. So what is this operator doing? This operator is saying x star y is basically, sorry, yeah, let's just call it a star. X star y is xy plus 2, x times y plus 2 divided by x plus y. So if I want to go and find 3 star 4, so if I want to find 3 star 4, I'm going to get, right, 3 star 4. What is 3 star 4? That's 3 times 4, 3 times 4 plus 2 divided by 3 plus 4. X plus y, this is x, that's y. Follow this rule here. So they're already giving you the rule to follow, right? That's your rule. So what's the answer we get here? We get 3 times 4, which is 12. We're getting 12 plus 2, which is 14 divided by 7, and my answer is 2 there. So all I'm doing now is I'm finding 2 star 2. So what is 2 star 2 now? Because I've already got the answer for this, which is 2 star 2. Now 2 star 2 is 2 times 2 plus 2 divided by 2 plus 2. So this on top I am getting 6 divided by 4, and my final answer is 3 over 2. Right, so guys, you need to select one of the options from your NBTs. Obviously you got A, B, C, D option, so you need to select the correct answer, which is 3 over 2. Right, let us move on. The expression y is equal to cos of x cubed plus x squared can be written as, so how can you write down this expression here? Now many people make a mistake and they take out x squared as a common factor, which is wrong. You can't take out x squared as a common factor, because this cos of x cubed is basically, this is the angle and it is cubed. It is not cos cubed x. So this is a trig function, and this here is a quadratic function, is a polynomial function, right? Polynomial function or quadratic function. So you can't mix up trig and polynomial functions. So basically all you can do over here is you can write down the correct answer, which is y is equal to cos of the angle cubed plus x squared. So we need to look at which one of the options is written in this form. So x squared, can you see, so obviously A is incorrect. Let's look at x squared plus cos of x cubed, so that's the one, right? Can it be this one? No. Cos of x all cubed is basically cos cubed x plus x squared, so it can't be this one as well. This one, these two expressions are basically the same thing, so that's also incorrect, and you can't take out x squared as a common factor, which is incorrect. You can't take out a common factor from an angle. Okay, so the only possible answer is B. So that's how usually your solutions are given in, and you just have to go and shade in the correct multiple choice. Let us look at question 5. Find the fourth root of 2 to the power 4 to the power 8. Interesting question. When we're finding nth root, right, if you're finding the nth root of x to the power m, we usually write down the rule, which is x to the power m over n, inside over outside. So what we can say is, now we can apply the same thing over here, and we can say, right, what happens in this situation when we have 2 to the power 4 to the power 8. So therefore we got the fourth root of 2 to the power 4 to the power 8. So all we can say is just 2 4 to the power 8, and we're dividing it by 4, inside over outside divided by 4. So 4 to the power 8 divided by 4 is just 4 to the power 7. So 2 to the power 4 to the power 7, like that, right? And you will select the correct option, whichever one is suitable. Let's look at question 6. If w is thrice as big as x, so we know w, let's write down the equation. W is equal to thrice as big as x, 3 times x. X is 3 less than y. X is equal to 3 less than y, so y minus 3. And y is 6 times as big as z, and y is 6 times as big as z. So we want to find z in terms of w. So if you want to go and find z, so to start off with the third equation, so z is equal to y over 6, right? Then what is y? Y is x plus, therefore y is equal to x plus 3 from here. So we're going to write down x plus 3 divided by 6. And then what is x? Because we want z in terms of w. So x is, what is x? X is w over 3. So you got w over 3 plus 3 divided by 6. So divided by 6 basically means 1 over 6 into w over 3 plus 3 over 1. So let us simplify this on the numerator. So we got 3 here times 1 over 6. Let me just write the 1 over 6 at the end. What we have is w plus 9, and my final answer we should get is w plus 9 over 18. Right, and you will select the correct option thus provided for you. Let us look at question 7. Let us simplify this. So you got 2 minus 1/3 over 2/3. Best way to do it is separate it, right? So we're going to write 2 minus 1/3 divided by 2/3. So now when you're dividing, you need to multiply. So 2 minus 1/3, you can do an LCD there. So 3, 2 times 3 is 6 minus 1 times 3 over 2. So what we have in the first bracket, you can clearly see that the 3 and the 3 cancels out. So what we are left with here is 5 over 2. Right, and you need to select the correct option. Let us look at a more generalized form like this. So we got a minus 1 over b, right, divided by a over b. So we need to make this a over 1. This is another question, guys. So this is b. A times b is ab minus 1. When you have different LCDs, example half plus a third, right? When you have different LCDs, example, if you're multiplying out the LCDs, then you can always cross multiply. So 2 times 3, which is 6, right? And then 3 times 1, you can just cross multiply like this. Let me just put a highlight for you, and just, that's only in the case if you're multiplying out the denominator. So 3, 2 times 1 is 2. So you get 5 over 6. And just that's what I'm doing in these two problems, the previous problem and here. Alright, so multiplied by b over a, we need to multiply here because it's a division. We need to flip the fraction. So b and b cancels out, and your final answer is ab minus 1 over a. Let's look at question 8. If 1 over r1 plus 1 over r2 plus 1 over r3 is equal to 0, then r2 is equal to, right? This question is like changing the subject or the formula. So we can see the LCD is basically r1, r2, r3. So r1 cancel, we got r2, r3 plus r2 and r2 cancel out because taking this and dividing by that. R2 can go into R1, R2, R3, R1, R3 times R1, R3 plus R3 and R3 cancel. We got left with R1 and R2, which is equal to 0. When we have an equation and we do an LCD, the LCD falls off. And remember the restrictions are R1, R2 and R3 can't be equal to 0. So we want to solve for R2. Since we are solving for R2, remember this is R2 here and R2 there. So we're going to factorize the R2 from the first term and the last term. So you're going to get R2 into R3 plus R1, which is equal to, take this over. So if we take this over, we're going to get negative R1, R3. Therefore, R2 is now equal to negative R1, R3 divided by R1 plus R3. And that's your final answer. Right, so you need to go and correct, right, select the correct option. Let us look at question number 9a, which is surds, right? Problem on surds. Square root of 48 minus the square root of 27 all squared. nice way to do this is, let's write down what is square root of 48. Square root of 48 is basically equal to 16 times 3. So 16 times 3, which is, let's write it, 16 times 3, which is 4 root 3. And square root of 27 is basically equal to 9 times 3, so 3 root 3. So all you are doing is you're saying, alright, this is 4 root 3 minus 3 root 3 all squared. You don't need to go and square a binomial here, right? So 4 root 3 minus 3 root 3 is just root 3 squared, and what's the answer? 3. Let's look at the second problem, which is square root of 18. Square root of 18 is 9 times 2, which is 3 root 2. And square root of 8 is square root of 4 times 2, which is 2 root 2. So you're doing 3 root 2 plus 2 root 2 squared. No calculator, guys, so that's the reason why we're doing this. So 3 root 2 plus 2 root 2 is 5 root 2, and if we square it, we're going to get 5 squared, which is 25, and a root 2 squared, which is 2, and 25 times 2 is 50. So root 18 plus square root of 8 all squared should get the answer of 50. Right, this is a nice question. Right, if j and k are divisible by 5 and j comma k is an element of z, so we know j and k are integer numbers, which one of the following is not? So if a number is divisible by 5, how can you write an equation for that? Example, we know that 25 is divisible by 5, so I can write that answer as 5. But what is okay, let's take it. So what is this 5 over here? Basically this 5 is your quotient. I can take another number, let's just say 30 divided by 5, which is equal to 6. So this is like my second quotient. Right, so we can call it quotient 1. So if we're taking j and k and dividing it by 5, we can say, alright, so j is divisible by 5. We're just going to say that's quotient 1. Therefore, what is j equal to? J is equal to 5q1. Right, cross multiply. And k divided by 5 is basically equal to quotient 2. So k is just some answer. So k is equal to 5q2. Now we want to see if 2j plus 2k is divisible by 10. Right, so we want to check each one, which ones are true and which ones are false. Right. So what is 2 times j? What is j? J is basically 5q1. So you're going to say 5q1 and 2 times 5q2. You can see this is, you're getting 10q1 plus 10q2. So you get a common factor, and q1 plus q2. So this is clearly divisible by 10. So we can divide this by 10 and the answer will just be q1 plus q2. So this is true. The second statement, j times k is divisible by 25. Is it true? So j is 5q1 and k is 5q2. So we're getting 25q1 q2, 25q1 q2. So you can clearly see that you can divide this by 25 as well. You're going to get an answer of q1 q2. So the second one is also true. Is j plus k divisible by 10? So j is 5q1, k is 5q2. So you can take out 5 into q1 plus q2. You can clearly see that this is, you can't divide this by 10, alright, so this is not divisible by 10. It is actually divisible by 5. J plus k is actually divisible by 5, not 10. So this is the false statement. Let us just check the last one. So j is 5q1 squared plus 5k is 5q2 squared. Right, so 5q1 squared is going to give us 25q1 squared plus 25q2 squared, second quotient squared. So you can take out 25 as a common factor. You're left with q1 squared plus q2 squared on the inside, not on the outside. And you can clearly see that this is divisible by 25. So the last one is also true. So the incorrect statement is C. Right. So guys, this brings us to the end of our session on algebra, right? And if you have any questions, please don't forget to comment. And if you want to contact me, you can go onto my main page and contact me on my email address. And please don't forget to like and subscribe to this video channel, and I will keep you posted. Don't forget to click on the bell icon as well. Please don't forget to watch the video on trigonometry. Take care guys. Thank you.